Hello everyone, welcome to this video. In this video, we shall be looking at another question from GATE 2002 examination from the subject of abstract algebra. This question here says that we need to find the number of elements, right, which are having order 5 in the symmetric group or the permutation group S5. So this is the question. So in this question, we all of us know that the order of the symmetric group S5 is given by 5 factorial, right? This thing we already know. Now we shall be making use of this result. The result here tell us that the order of permutation of a finite cycle. So here we need to find how many such permutations would be there of order 5, right? So they are calculated whenever they are written in disjoint cycles, and the length of and then we take the LCM, the least common multiple of the lengths of the cycle, right? So whatever is the LCM of the lengths of the cycle, that many permutations are obtained of such order. For example, in our case, because we are in the group S5, right? So what we do, we partition this number 5 here, because we wanted to see how many different cycles are there which would have different lengths, how many different cycles are there, right? So that means in how many ways we may arrange these 5 elements. So the partitions of 5, they are 5, 4 plus 1, 3 plus 1 plus 1. We are not writing 1 plus 1 plus 3 because that is exactly the same thing, because the cycles commute. It means that we have one cycle and a 3 cycle. Similarly, this thing, a 3 cycle, a 1 cycle and 1 cycle, they are the same thing. So we are just writing the one way of this partition. Okay, so the next element is 3 plus 2, the next element is 2 plus 1 plus 1 plus 1, and the next element is 2 plus 2 plus 1, and the last element is 1 plus 1 plus 1 plus 1 plus 1 5 times, right? So these are the only possible partitions of the number 5. Now these numbers here represent the length of the cycle. So what we are going to do here, we are going to take their LCMs. So you see the LCM in the first partition is 5, in the second one it is 4, then 3, 6, 2, 2 and 1. Correct? Now we are interested to look at the elements which are having order 5. So that means we are going to look at the LCM which is coming out to be 5. So this is the only case. So that means we would have a cycle of this kind where we have 5 elements present in a cycle. So we would have a 5 cycle. So corresponding to order 5, we would have only 5 cycles which are of this form. So now we need to see how we may arrange these 5 elements within this cycle in order to have the number of permutations which are having the order 5, correct? So we know in total there are 5 factorial elements which are present within this group S5. Now in how many ways we may able to choose A1, A2, A3, A4, A5 from these numbers, right? These are the numbers on which the permutations are defined. So so that we are able to get the number of permutations which are having order 5. So therefore you see the first element A1 has 5 choices. We may select out of these 5 numbers any one number in place of A1. For the next element, as A1 is fixed, we have just left with 4 numbers. So that means 4 choices are there for A2. Now A1 and A2 are fixed. For A3 we have only 3 choices with us. So therefore we will substitute 3 here, and similarly 2 here and 1 here. So there are 5 into 4 into 3 into 2 into 1 way in which we may arrange A1, A2, A3, A4, A5 in this 5 cycle, correct? However, here these elements, these permutations A1, A2, A3, A4, A5, here A1 maps to A2, A2 maps to A3, A3 maps to A4, A4 maps to A5 and A5 maps to A1. So here also A2 maps to A3, A3 maps to A4, A4 maps to A5, A5 maps to A1 and A1 maps to A2. You see the mapping is the same here. So this and this they represent the same permutation. Why? Because they are mapping the same element to the same element. However, when we are choosing the elements in this way, we are taking them as different permutations. So therefore all these 5 permutations, they are the same, however we are taking them to be different, so that we may divide the number of ways in which we may choose the elements a1, a2, a3, a4, 5 by 5. When you so that we have only the different cases with us, so that this numbers come out to be 24. So that means in total the number of elements which have order 5, they are 24 in number, and hence as the correct answers we have option C as the correct option. So I hope you understood the answer to this question. Well, that is it for this video. Thank you for watching.